All right, if you haven't already done so, want you, well, second hour because they've been looking at this, but what I need everybody to start with here is drawing what appears to be, it's a trapezoid. I had a question, do we want A, B, and C, D to look the same? And not necessarily. I do want your letters to be in the same places with the A, B, C, D in the same places on my figure, on your figure as they are on mine. These notes are required. This isn't an optional activity. You're gonna get everything about the 7-5 lesson in these notes. Again, make sure your letters are in the same place mine are. I didn't have rulers in people's hands. I think you guys can live without that today. I think, what's today, the 18th? Yeah. Seniors got just another 19, 17, 18, 19. Oh, I can't wish away that much time. A month I can wish away, but not 3 years. No thanks. All right, let's get into some of these definitions. So what we have, just to the basics of how we define a trapezoid, it's a quadrilateral with exactly one pair of parallel sides. Quadrilateral with exactly one pair of parallel sides. A quadrilateral with exactly one pair of parallel sides. Now, in addition to writing out that it has exactly one pair of parallel sides, I want you to come over on your drawing and we're going to actually mark side BC parallel to side AD. So I'll make that statement here. BC is parallel to AD. Oops. And they're segments, so I'll put those over there too. So exactly one pair of parallel sides. And we're going to talk about the rest of these parts like on this drawing. So every time we write a definition, we'll make sure it's reflected on that sketch so you guys know what to look for. The bases are considered to be the parallel sides of a trapezoid. The bases are the parallel sides of a trapezoid. So that makes BC a base. And it seems weird because it's at the top, but this is just the way it's defined. And AD is also considered a base. The parallel sides of a trapezoid. So the base is the top and the bottom. The parallel sides of a trapezoid, and it really looks like the top and the bottom in our drawing. The base angles, actually let me tell you about, let's see, so the bases are, let me do this, the bases are BC and AD. Now the base angles are actually in pairs. Angle B and angle C is a pair of base angles, and we also have angle A and angle D as a pair of base angles. And the definition of it is that it's two consecutive. Consecutive means next to each other. Oh, I didn't spell that right. Consecutive. U-T-I-V-E. Two consecutive angles whose common side is a base. So A and D are a pair, B and C are a pair. I don't know if I really want you to put any arrows in there. We put over here what they are. Two consecutive angles whose common side is a base. This is our last set of Chapter 7 notes. If there's any notes that you're missing in your packet up until this, you have basically until like tomorrow or Friday to get these notes together, because it's what you're going to be using for your review and studying for your test. If you've been absent, it's on you to get somebody else's notes, or Thursday in class you could actually ask me if you're missing something and you want to take a look at mine. But if you were absent for any parts of the notes in this packet, it's your responsibility to be getting that from somebody. So the legs of a trapezoid are the non-parallel sides. Non-parallel sides. So if I name the legs are the A, B, and C, D sides. So A to B is a leg, C to D is a leg. The non-parallel sides, and I wrote it as A, B, and C, D, as well as putting leg in leg on my drawing. Now, a isosceles trapezoid. This is not a picture of an isosceles trapezoid, and the reason why this one is not is because an isosceles trapezoid is a trapezoid with legs that are congruent. And I asked you specifically, I'll get it later. An isosceles trapezoid is a trapezoid with legs that are congruent. And I asked you guys specifically to make A, B, and C, D not look the same. So we don't have a picture of an isosceles trapezoid yet, but we'll be talking about them as we look at some theorems. I'm going to maybe even put over here, not pictured yet. It's not in our picture because we wanted those to look like they weren't the same. If you went to South Lake Middle School, I know, like, even in my husband's classroom, the tables in there were trapezoid shapes, like isosceles trapezoids. You know what I'm thinking of? Yeah, little trapezoid tables. Now, a mid-segment of a trapezoid is the segment that connects the midpoints of the legs. So the segment that connects the midpoints of the legs of a trapezoid. A segment that connects the midpoints of the legs of a trapezoid. And this one isn't pictured either, but we'll get to it when we look at our theorems. Look on the next page, we'll see what they mean. Midpoints, middle place, the legs are going to be the non-parallel sides. And then a kite is actually a completely different quadrilateral. I'm going to sketch a kite over here. Back in elementary school, you guys probably called these a diamond early on. It's not really the technical name, but I'm putting some markings on this kite. The markings are going to go right along with what the definition is. Mid-segment, a segment that connects the midpoints of the legs of a trapezoid. And then I just sketched this kite over here. So a kite is a quadrilateral with two pairs of consecutive congruent sides, two pairs of consecutive, I keep spelling consecutive wrong, U-T-I-V-E, consecutive congruent sides, but opposite sides are not congruent. Two pairs of consecutive congruent sides, but opposite sides are not congruent. So my markings on my drawing, these two guys touch, they're consecutive sides, a single mark to show those are congruent. These two guys touch, consecutive sides, those two are congruent. Quadrilateral with two pairs of consecutive congruent sides, but opposite sides are not congruent. Now we get into some of the rules, you know, our theorems about stuff. Pay attention to the fact that this one only applies to isosceles. We see in theorem 714 the isosceles markings sitting here. AB is congruent to CD. If a trap is isosceles, those marks are there. Then each pair of base angles is congruent. B and C will be the same. A and D will be the same. So that's a relationship we're going to go on and do some practice together, and that's a relationship that we'll look for. If we know one of them for B, we'd figure out C. If we know, well, actually, I'm getting a little bit too far ahead of this. But if I knew what B and C were, I could also figure out what A and D were. Don't forget this is three-sided. And just a little reminder out to the side that the sum, I'm sorry, three-sided, it's four-sided. The sum is going to be 360. So I'm sure we're going to be using some subtraction and dividing by 2 to figure out what some base angles are. The converse of the base angles theorem, look at what you start out with. You know that these sides are the same. It's isosceles. You also, well, you know the sides are the same, and if you know this pair of base angles is the same, then that gives you the ability to call it an isosceles. So if this is given, you can conclude. If this is given, then you can conclude this. If it's given that the base angles, one pair of base angles and the sides are the same length, you can draw the conclusion that it's an isosceles trapezoid. Written as an if-then. Got a couple notations to do on the rest of the theorems, the given and the conclude. Turn in my page. Couple things about the rest of these rules, and you'll of course come back and reference these while you're working on your, while we're doing the practice together, we'll look back at it, and then when you're working on your assignment for this too, you can come back to all these rules. A trapezoid is isosceles if and only if its diagonals are congruent. So the only thing I want to say about this is that you may wind up doing the distance formula. Squares and adding to show same length. So in the coordinate plane, this is something that you've got to consider. Diagonals theorem, the diagonals are congruent. And then here's that mid-segment theorem that we got the definition of a mid-segment on the other page. And so right here we see those mid-segments, and we actually see the midpoints dropped in and the congruent marks to show that that M split AD in half, and the congruent marks to show that N split BC in half. And then we've got all of our parallel lines. In this trapezoid, the base angles as well as the mid-segment are all parallel to each other. I'm sorry, the bases as well as the mid-segment are all parallel to each other. So this right here is parallel bases and mid-segment. And then the relationship is that the mid-segment, and I'm going to write it in words, the mid-segment, they're calling it MN, is equal to half of the sum of the bases. Add up the lengths of the bases and take a half, and that's how long the mid-segment is. And you know what? Again, your distance formula may come up when you're having to find lengths in the coordinate plane for a mid-segment. Add up the base lengths, and you'll take half of it, and you have the mid-segment length. So let's see here. Moving on to a couple things about kites. Kite diagonals theorem. If a quadrilateral is a kite, you see the same markings we had drawn on the other page. Then the diagonals intersect at a perpendicular angle. Diagonals intersect at 90 degrees. Diags intersect at 90 degrees. In a kite, we have exactly one pair of opposite angles that are congruent. Look at where they are. Pay attention to where those opposite angles are congruent. How can I say this? So you guys see they even showed B and D are not the same measure. You can tell by looking at it too. It's the congruent angles. I'm going to say this in the note. The congruent angles, this may sound funny, but I think you can make sense of it. The congruent angles are formed by the intersections of the non-congruent sides. So these two are not congruent to each other, but the angle they form is congruent to the angle formed by the others. The congruent angles are formed between non-congruent sides. Between non-congruent sides. The congruent angles are formed between non-congruent sides. Right here. BC is not congruent to CD. It's this angle. BA is not congruent to AD. It's this angle. I know it sounded kind of funny. That's why I wanted to just some other way to think about it. Like, which ones do you pick? I feel like you can tell which ones look alike, but at the same time, we always have to be careful about how things look. So far, so good?